Hello students, good evening. So welcome to the session 16 of electrostatic potential and capacitors. In Canada, we'll continue with our discussion about the capacitors with the dielectrics. As already we have talked about how do we calculate the resultant capacitance. Okay. So if you are filling up the space between the two plates by different medium, how do we calculate the equivalent capacitance and சொல்லலாம் or the resultant capacitance? அது already நம்ம cover பண்ணிருக்கோம் in session 15. Okay. So இன்னைக்கு என்னன்னா we'll start with the idea of what is the effective dielectric constant. ஏன்னா இந்த concept based பண்ணி we already got a question in the previous years. Okay. So it's nothing new. ஏன்னா because already we talked about the method to find the equivalent capacitance. இங்க பாருங்க like this one already we solved. Session 15 we solve this question, right? So இந்த மாதிரி நம்ம ஒரு ரெண்டு மீடியம் வச்சு fill பண்ணா where for a width d2 d by 2 we are having a medium k1, அதுக்கப்புறம் d by 2 we are having medium k2. like இப்போ if you rotate it and see it like this, right? இப்படி வரும். Okay, so it will come like this. How it is going to come? இந்த மாதிரி like you will have medium 1. Okay, like this is how it is connected. So in the bakkanana medium 2. Okay va? And we talked about it. It's like what? Two capacitors in series madri. Is C1 and C2 series madri. Okay, so we already got the expression for the equivalent capacitance. Other value na 2 times A epsilon naught by D into K1 K2 by K1 plus K2. In the result namakita already irukka. இப்போ பாருங்க, what is the idea of the effective dielectric constant? Effective dielectric constant என்ன தெரியுமா? இப்போ இங்க என்ன இருக்கா? ரெண்டு மீடியம்ஸ் இருக்கா. ஓகே, அப்படியே அந்த ரெண்டு மீடியம்ஸ் நம்ம ரிமூவ் பண்ணி ஒரே மீடியம் வச்சு நம்ம ஃபில் பண்ணா what is going to happen? Let us say that we are filling up the space between the capacitor plates by using just one single medium. Okay, so இந்த மாதிரி ரெண்டு மீடியம் இல்லாம we'll just fill the space by using just one single medium. And that single medium dielectric constant, that is what we are going to call as K effective. So whatever the single medium we are using to fill it, right? What is that dielectric constant of that medium going to be called as effective dielectric constant? That is the K effective. Okay va? இப்போ சொல்லுங்க, what will be the same area of cross section எவ்வளவு A? What is the distance between the two plates? D. இப்போ what is the capacitance value? K effective times A epsilon naught by D. அப்படிதானா? Like if you replace all these, இங்க என்ன இருக்கா? There are two mediums given. அதெல்லாம் நம்ம அப்படியே remove பண்ணிட்டு just keep one single medium with a dielectric constant. அதுக்கு என்ன? What is the name we are giving for that? K effective ன்னு சொல்லிட்டு அப்படி நம்ம replace பண்ணா what is the capacitance value going to be? K effective times, ஏன்னா இங்க எப்படி ஒரே மீடியம் வச்சு நம்ம replace பண்ண மாதிரி தானா? So if you are keeping a single medium means what is the capacitance value? K times A epsilon naught by D, right? So the capacitance value என்ன வருது? K effective times A into epsilon naught by D. அப்படியே நீங்க இந்த ரெண்டு ஈக்குவேட் பண்ணுங்க. So what is it? K effective times A epsilon naught by D. அப்படியே ஈக்குவேட் பண்ணா we will be able to cancel A epsilon naught by D. So இதுல இருந்து what is the K effective value coming for us? 2 times K1 K2 by K1 plus K2. இதுதான் effective dielectric constant. இது எப்படி தெரியுமா? Like whatever the overall capacitance, இப்போ இந்த மாதிரி நம்ம அரேஞ்ச்மெண்ட் பண்ணா what is the overall capacitance? If you replace that entire space by ஒரே மீடியம் வச்சு நம்ம replace பண்ணா அதோட dielectric constant என்னது? That is the K effective value. Okay, so பாருங்க sample, for example number, right? K1 நீங்க ஒரு 2 எடுத்துக்கோங்க. K2 is equal to some maybe 8. இப்போ பாருங்க what is the effective dielectric constant value? 2 times K1 into K2, and then the 2 into 8 16 divided by K1 plus K2 on 2 plus 8 10 dana, which is what? Numerator 32 divided by 10, which is what? 3.2. Paranga, like if you are having one medium dielectric constant 2, இன்னொரு medium dielectric constant 8, அப்படி நம்ம fill panna, whatever is the effective capacitance coming, right? If you take that same capacitor arrangement and fill it with a medium having a dielectric constant 3.2, you are going to get the same result. The capacitance value will be what? Same. That is the idea. Okay va? So whatever is the arrangement given to us, right? Remove panni, we can just replace this with a single dielectric material, and the dielectric material dielectric constant we are calling as what? Effective dielectric constant. Okay va? So this is the concept of the effective dielectric constant. In one example, this is also we have covered already session 15 in the what is it? Same. Rotate what is it that you are going to observe? If this is how it is going to come. Okay. So it is like what? It is like what? A by 2 that is filled with medium K1. That is another A by 2 that is filled with medium K2. These two capacitor like what? Parallel setup. We are even able to find out what is the capacitance value. Okay, the equivalent capacitance value, what is it? A epsilon naught by D into K1 plus K2 by 2. This is what is the equivalent capacitance of this particular arrangement. Okay va? So same concept, right? Effective dielectric constant calculate pannom. Think of it same and the setup geometrical setup will be as it is. The area of the plates A, the distance between the plates is D. Okay, but difference is we are thinking that okay, we are replacing the entire medium by one single and the medium mode dielectric constant K effective. Okay, what is the capacitance value? K effective into A epsilon naught by D. Whatever the arrangement, they are giving two mediums. Remove we just replace this with a single medium. The single medium mode dielectric constant effective dielectric constant. Okay, so our capacitance value K effective times A into epsilon naught by D. So this should be equal, right? Okay va? In the two expressions we equate A into epsilon naught by D cancel K effective is equal to what? K1 plus K2 by 2. So this is the approach. So the effective dielectric constant we calculate we should first get what is that equivalent capacitance, and the equivalent capacitance we will be able to calculate the effective dielectric constant. This is not like a separate problem. First, on the equivalent capacitance value we have to find it out. Equivalent capacitance just we will equate it to what? K effective times A into epsilon naught by D. Ella setup remove just we are keeping one single medium. And the ideal what is that dielectric constant of the medium? We are giving a name. What is it? Effective dielectric constant and solid. Okay va? So first we should find out what is the equivalent capacitance. And the value we will be able to find what is that effective dielectric constant. Okay va? So this is the approach to calculate what is the effective dielectric constant. Okay, so we will try to look at one question that has already come in the previous year. This is the question that has come in the previous year NEET la vandhathu. This is like 4 medium irukka. Okay, so we are filling up the space between the capacitor plates by using 4 dielectric medium. Okay, a parallel plate capacitor area A, separation D, and a capacitance C is filled with 4 dielectric materials. Other dielectric constant values are K1, K2, K3, K4 in another arrangement. Okay va? If a single dielectric material is to be used to have the same capacitance C, other than a basic concept of and the effective dielectric constant or concept whatever arrangement this arrangement, it is giving a capacitance C in vechkonga. Adukulla irukra ella materials nama remove panni we replace this with a single material that is going to give us the same capacitance value. Okay, So that material dielectric constant தான் நம்ம என்ன சொல்லுவோம் effective dielectric constant. Okay, so பாருங்க, if this single dielectric material is to be used for giving the same capacitance, then the dielectric constant K of that material, so avanga அந்த effective dielectric constant அந்த word use பண்ணலாம், but what they are asking us to find, they are asking us to find what is the effective dielectric constant. The word மட்டும் யூஸ் பண்ணலாம், but they have actually given the definition itself. இங்கே அவங்க அந்த definition கொடுத்திருக்காங்க. What is it? They are having 4 different mediums, right? அது எல்லாத்தையும் அப்படியே ரிமூவ் பண்ணிட்டு just replace all of them with a single medium. அப்படி ரீப்ளேஸ் பண்ணா what is the dielectric constant of the medium K? அதுதான் அவங்க கேக்குறாங்க. Okay, so இங்க என்ன பாருங்க, the relation is given. K is equal to K1 plus K2 plus K3 plus 3K4. அந்த மாதிரி we are having 4 relations, 4 relations இருக்கா. இதில் நம்ம அந்த relations பார்த்துட்டு there will be no benefit. We have to just go on. First என்ன பண்ணணும், we should solve for what is the equivalent capacitance. அப்படிதானா? So இதுக்கு என்ன தெரியுமா, so we have to rotate this. ஏன்னா because we are used to seeing the capacitor like this, right? Plate area vertically place பண்ண மாதிரி, that is our normal way of seeing the capacitor. Okay, பாருங்க, this is how we have these capacitors. இங்க என்ன தெரியுமா, it is like what, C3, இங்க பாருங்க, C3, C2, C1. அது எப்படி, it's like these 3 are in parallel. ஓகேவா? அதுக்கு அப்படியே C4 is in series. பாருங்க, what is setup? C3, C2, C1. All 3 are like what? Parallel. பாருங்க, so why are you able to say parallel? இங்க பாருங்க, இங்க நீங்க டெர்மினல் பிளேஸ் பண்ணி வச்சுக்கோங்க, they are connected. அந்த மாதிரி இங்கேயும் அப்படிதான், terminals are connected அந்த மாதிரி. So C3, C2, C1 எப்படி இருக்கா, they are all parallel. அப்படியே அந்த full in the block பாருங்க, this block is in series. ஏன்னா this is the common இது ஃபுல்லாவே common side, right? Which means what, that full block, the C3, C2, C1 அந்த block ன்னு சொல்லலாம், or that parallel block ன்னு சொல்லலாம், that is in series with the C4. ஓகேவா? So this is the main important thing. Once you are able to get it right, so ஏன் இப்படி வருதுன்னு, that's so we need to be thinking. ஏன்னா because C3, C2, C1 they are like what, terminals collect பண்ண மாதிரி இருக்கா, so they are like parallel. அதுக்கு அப்படியே that entire arrangement, right, இந்த parallel arrangement ஓட பக்கத்துல we'll have the C4 kept in series. So C4 will be in series with this particular branch. இந்த ஃபுல்லா இந்த parallel block ஓட it will be coming in the series. ஓகேவா? so இதுதான் main important step. இது வந்ததுன்னா we are able to get the answer. அவ்வளவுதான். இப்போ பாருங்க, தனித்தனியா we will write down these values. C1 எவ்வளவு பாருங்க, what is C1? A by 3 K1 வரும். Okay, K1 A by 3 epsilon naught. இதனை the distance between the plates எவ்வளவுங்க, D by 2. Okay, so இதை பாருங்க, இந்த denominator இருக்கிற 2 அப்படியே numerator போயிடும். So 2K1 A epsilon naught by 3D. அந்த மாதிரி நீங்க அப்சர்வ் பண்ணுங்க. C2 ஆகட்டும், C2 also will have a similar formula, 2K2 A epsilon naught by 3D. அந்த மாதிரி C3 ஓட வேல்யூ அப்படிதான் வரும். What is it? It will be 2K3 A epsilon naught by 3D. ஓகேவா? இப்போ all these are in what? Parallel தானா? Parallel means what? இதோட equivalent. Equivalent of 1, 2, 3. அதனது parallel means what? Just C1 plus C2 plus C3 தானா? Which means what? எல்லாத்தையும் ஆட் பண்ணுங்க. What is it? எல்லாத்தையும் ஆட் பண்ண என்ன வரும்? அப்படியே we can just take that 2 by 3 A epsilon naught by D நம்ம காமன் எடுக்கலாம். காமன் எடுத்தா what is it remaining? K1 plus K2 plus K3. இதனது this is the equivalent of that capacitor 1, capacitor 2, capacitor 3. ஓகேவா? So first step is over. அடுத்த step என்ன? We will look at the capacitance of that C4. இங்க பாருங்க, C4 ஓட capacitance. C4 capacitance எவ்வளவு வரும்? Distance between the plates எவ்வளவு? இது என்னது? D by 2. But area A. Full area. ஓகேவா? So பாருங்க, C4 is equal to what? K4 into area A epsilon naught divided by D by 2. இங்க அப்படி தான் 2 numerator போய்டும். What is it? 2 times k4 a epsilon naught by d. ஓகேவா? So then this is c4 value. But overall and சொன்னா what is it? பாருங்க, c3 or this combination, the parallel setup is in series with c4 தானா? parallel setup and சொன்னா அதோட equivalent value already நம்ம கிட்ட இருக்கா, c1, 2, 3. okay, that is in series with c4, right? If two capacitors are in series, அதோட equivalent formula என்ன? capacitance 1 into capacitance 2 by capacitance 1 plus capacitor 2. அதுதானா? so if you are having பாருங்க, two capacitors c1 and c2 are in series னு வெச்சுக்கோங்க. what is the equivalent of them? c1 c2 by, so இதெல்லாம் basic formula, so we should be very clear with it. okay, அதோட equivalent என்ன? c1 c2 by c1 plus c2. okay, so அந்த formula வெச்சு we will try to write down the overall equivalent capacitance. பாருங்க, what is the overall equivalent capacitance? so overall equivalent capacitance இப்போ நம்ம எழுத போறோம். what is it? this into this, so 2 times k4 a epsilon naught by d into 2 by 3 times a epsilon naught by d into k1 plus k2 plus k3. ஓகேவா? divided by என்ன வரும்? what is it? we have to add both of them, right? இப்போ என்ன வருது பாருங்க, என்ன வருது? what is it that is going to come? c1 c2, which is what? 2 times k4 a epsilon naught by d plus 2 by 3 times a epsilon naught by d into k1 plus k2 plus k3. ஓகேவா? this is our c equivalent value. this is the c equivalent value. ஓகேவா? so இதுல இருந்து we have to find out what is the effective dielectric constant. we have to find out what is the effective dielectric constant. okay, so இப்போ பாருங்க, what is it that we will have? so numerator denominator we can cancel, என்ன நம்ம cancel பண்ண முடியும் பாருங்க, 2a epsilon by d நம்ம cancel பண்ணலாம். cancel பண்ணா what will be the remaining thing? அவ்வளவுதான். இதுக்கப்புறம் வெறும் அந்த simplification மட்டும் பண்ணணும். இதுக்கப்புறம் என்ன இருக்கும்? just we have to keep on simplifying, அவ்வளவுதான். cancel பண்ணா what is it that is remaining? numerator பாருங்க, what is there in the numerator? k4 times 2 by 3 a epsilon naught by d into k1 plus k2 plus k3, that will be remaining. denominator la what is there? idanadi k4 plus k1 plus k2 plus k3 whole by 3. okay va? so this is the equivalent capacitance. equivalent capacitance is, what is it? if you replace all of them by a single medium with a dielectric constant k, அதோட capacitance value வந்து k times a epsilon naught by d. அதுதானா? இப்போ திருப்பி இந்த a epsilon naught by d cancel ஆயிடும். so அடுத்து என்ன வரும் பாருங்க, k is equal to 2 by 3 into k4 into k1 plus k2 plus k3 divided by denominator என்ன இருக்கா? what is there in the denominator பாருங்க, 3 times k4 plus k1 plus k2 plus k3 divided by 3. okay, so 3 cancel ஆயிடும். so இங்கல இருந்து we have to find out which of those அங்க கொடுத்த expressionsல what is the one that is matching. okay, so இங்க பாருங்க, what is the options? இப்போ என்ன, we have to look at the options and then simplify. okay, so இப்போ என்ன நம்ம கிட்ட what is there with us? k is equal to what? 2 times k4 into k1 plus k2 plus k3 divided by 3k4 plus k1 plus k2 plus k3 is that is what is the k oda value. Okay, so இப்போ பாருங்க options la பாருங்க what are the options that are there. Option A la they are saying k is equal to straight away கண்டிப்பா இது கிடையாது. Okay, option B லயும் அப்படிதான் they are saying k is equal to 2/3 into கண்டிப்பா அதுவும் கிடையாது. Okay, so option C and D la பாருங்க they are giving reciprocal of k கொடுத்திருக்காங்க. Option C and D la பாருங்க they are giving what reciprocal of k. Okay, இங்க என்ன இருக்கா 2/k இருக்கா, இங்க என்னது 1/k. இப்போ நம்ம என்ன பண்ணலாம், so இங்க இருந்து we'll just try to write down the reciprocal of k. Reciprocal னு சொன்னா அப்படியே we have to flip it, right? இங்க பாருங்க, so 1/k is equal to what, right side la பாருங்க what is there, right side la what is it that we'll have 3 times k4 plus k1 plus k2 plus k3. okay வா, denominator என்ன 2 times k4 k1 plus k2 plus k3. இப்போ என்னன்னா அப்படியே நம்ம split பண்ணி எழுதலாம். so we'll just try to split and write. Split means what, split பண்ணா what is it that we'll be having பாருங்க, first 3k4 by 2k4 into அதெல்லாம் வரும். okay, so which means what, adula k4 cancel ஆயிடும். what we will be having, this will be remaining, what is it 3/2 into k1 plus k2 plus k3. okay வா, so அடுத்து என்ன பாருங்க, second term நம்ம split பண்ணா அதுல k1 plus k2 plus k3 cancel ஆயிடும். okay, so remaining will be what 1/2 k4. okay, so என்ன வருது பாருங்க, what is it that we are having, so இங்க நம்ம எழுதலாம் 1/k is equal to what is it that is there 3/2 into k1 plus k2 plus k3 plus 1/2 k4. okay, so இங்க என்ன தெரியுமா, இங்கேயும் 2 இருக்கா இங்கேயும் 2 இருக்கா, அப்படி நம்ம காமன் எடுத்துட்டு we can just take it to the left side, it will go to the numerator. பாருங்க, so numerator என்ன வரும் 2 வரும் left hand side la, 2/k is equal to what 3/k1 plus k2 plus k3 plus 1/k4. இப்படிதான். so இங்க என்ன we just have to do some mathematical adjustment. ஏன்னா அவங்களுக்கு கொடுத்த ஆப்ஷன் எப்படி இருக்கா, like it is in terms of the reciprocal of k, so அதனால we also have to do that reciprocal. okay, so இங்க என்ன we'll just have to get, so இந்த மாதிரி effective dielectric constant problems என்ன தெரியுமா, we'll have to first get what is our equivalent capacitance. வந்ததுக்கு அப்புறம் அதுல இருந்து we'll be able to comment on what is the effective dielectric constant. அதுதான் basic concept. ஓகேவா, so அடுத்தது என்னன்னா it's like a very standard result மாதிரி, இது நம்ம derive பண்ண தேவையில்லை, but just look at it. so இதுக்கு முன்னாடி நம்ம பார்த்தது என்ன, we were filling it like you know அந்த horizontal crossing இல்லைன்னா vertical crossing அந்த மாதிரி. இங்க பாருங்க we are filling the medium with a diagonal crossing. The capacitor is a standard problem. okay, a capacitor is formed by two square metal plates of edge A, means area of cross section எவ்வளவு பாருங்க small a square. ஏன்னா because it is a square plate and சொன்னா what is the area of the plate, edge length the square, right? They are separated by a distance d. Dielectrics of dielectric constant k1 and k2 are filled in the gap. எப்படி fill பண்ணிருக்கோம், with a diagonal crossing வர மாதிரி. ஏன்னா நீங்க பாருங்க, so இதுக்கு முன்னாடி நம்ம பண்ணது என்ன, we were either filling it like this இல்லனா we were filling it like this, right? horizontal crossing இல்லனா vertical. so இங்க என்னது diagonal crossing fill பண்ண மாதிரி. okay, so இது என்னன்னா we will have to solve this. இப்போ இதோட equivalent capacitance நமக்கு வேணும்னா we will have to solve this by using the integration approach. but இங்க அந்த derivation நம்ம பண்றது கிடையாது, we are just looking at what is the final result. okay, so final result எவ்வளவு மட்டும் பாருங்க, what is it, the capacitance, the effective capacitance or equivalent capacitance of this, அதோட வேல்யூ என்ன epsilon naught into a square by d So A square and sonna you can think of it like what, capital A madri, which is the area of the plate, okay va, into, so the multiplication factor is important. What is it? K1 K2 by K1 minus K2 into ln K1 by K2. என்னது பாருங்க, K1 K2 by K1 minus K2 into ln K1 by K2. So in the result மட்டும், if you are remembering means that is sufficient. ஏன்னா இந்த மாதிரி questions they will not generally ask, but if at all there is a question like this, right, we will be able to easily answer it, okay va. So what is it? It is like filling the materials with separate medium with a diagonal crossing fill பண்ண மாதிரி. So எங்க என்ன தெரியுமா, if this is the equivalent capacitance, we can tell what is the effective dielectric constant. இப்போ இந்த கேஸ்ல effective dielectric constant என்னது பாருங்க, whenever we have the equivalent capacitance, right, just write it like this. இந்த மீடியம் ஃபுல்லாவே நம்ம ரிமூவ் பண்ணிட்டு just replace this with a single medium. அப்படி நம்ம replace பண்ணா the capacitance value will be what, K effective times A epsilon naught by D, right. அப்படியே அந்த A epsilon naught by cancel ஆயிடும். So இங்க பாருங்க, what is the K effective value? K effective value பாருங்க, K1 K2 by K1 minus K2 into ln K1 by K2. Okay, so இது என்னது, this is the effective dielectric constant of this particular way of filling the dielectric medium. Okay, so இங்க என்னன்னா we are filling with the two different materials. Okay va. So this is about the dielectrics in the capacitor. அடுத்தது என்னன்னா we are going to look at some additional scenarios. So additional scenarios என்னன்னா, like we don't usually expect questions. இந்த ஏரியால இருந்து we don't usually expect questions to come, but these are some of the additional things. If you are able to cover means it will be good. Or that, I mean, if at all there is a question coming from this area, we will be able to answer them. Okay, so look at this. Additional scenarios. Additional scenarios, we are going to see the modification of the spherical capacitor. Already spherical capacitor patti we have talked about it. Okay, so if spherical capacitor enadhi, veru you take a conducting sphere, adana. What is spherical capacitor means? Conducting sphere. Inga paranga, we are taking a conducting sphere for which we are giving a charge Q, radius of the sphere R. So what is the potential on the surface of the sphere? Potential formula enna, KQ by R for a conducting sphere, right? What is the potential on the surface of the sphere? KQ by R, otherwise 1 by 4 pi epsilon naught Q by R. That is what is our potential. Then the corresponding capacitance value. Now we already did this. Capacitance means what? Charge by potential. Capacitance means what? Charge by potential. Paranga, what is the corresponding capacitance? Charge by potential panna. This is the potential, right? So paranga, Q divided by potential means what? 1 by 4 pi epsilon naught Q by R. Q appadi cancel adu, mathadella numerator la poidum. Okay, what is it? 4 pi epsilon naught into R. This is the capacitance of a spherical capacitor. In the result already nama paathirukom. Okay, so this is the capacitance of the spherical capacitor. Even now we have even derived what is the capacitance of the earth. Just we have to take the radius of the earth. So radius of the earth, if you take it like 6,400 kilometers approximate, we will be able to find what is the capacitance of the earth. Okay va? All that we have covered. We are going to see some modifications of the spherical capacitor. Okay va? The modifications we will look at some of the questions that can be asked on the comparisons. Comparison enna theriyuma parunga, like in the madri, these are all quick questions. Neat la varathukku there will be some scope. Two conducting spheres, other radius R1 R2 are at the same potential. Two conducting spheres, conducting sphere and sonna, that is like our what? Spherical capacitor. Rendu one dana. A conducting sphere is like a spherical capacitor. Two conducting spheres, radius R1 R2 are at the same potential. Then the ratio of their charges R1 by R2. So in the madri questions there will be lot of scope. So they will give it like question, two conducting spheres, radius R1 R2 are at the same potential. Then the ratio of the charges is what? In options you will have R1 by R2, R2 by R1, R1 square by R2 square the madri. Okay va? What is it? The potential is same. Potential is same and sonna, what is the potential formula? இப்போ தான் நம்ம பார்த்தது. What is the potential formula? 1 by 4 pi epsilon naught q1 by r1. That is the potential of that first sphere. Second sphere will be what? 1 by 4 pi epsilon naught q2 by r2. ஏன்னா அவங்க என்ன சொல்றாங்க, the potential on both of them is same, means அப்படியே நம்ம ஈக்குவேட் பண்ணலாம். ஈக்குவேட் பண்ணா இதெல்லாம் கேன்சல் ஆயிடும். So the ratio of the charges means what? q1 by q2 நமக்கு வேணும். பாருங்க, rearrange பண்ணா what is q1 by q2? இது அப்படியே denominatorல வரும். r1 எங்க போய்டும்? numeratorல. So q1 by q2 is equal to what? r1 by r2. பாருங்க, this is the ratio of the charges when the potentials are same. இது ஒண்ணு. இங்க பாருங்க, two conducting spheres radius r1 r2 are equally charged, means charge is same on both of them. அப்ப என்ன calculate பண்ணனும்? The ratio of their potentials. இங்க பாருங்க, they are given same charge, means let us say the charge ஓட value q வெச்சுக்கோங்க. Then நமக்கு என்ன வேணும்? v1 by v2 வேணும். v1 is what? 1 by 4 pi epsilon naught q by r1. அதுதானா? v2 என்னது? 1 by 4 pi epsilon naught q by r2. ஏன்னா ரெண்டு ஸ்பியர்ஸ்ல we are having the same charge. இப்ப பாருங்க, இதெல்லாம் கேன்சல் ஆயிடும். So what is it? 1 by r1 divided by 1 by r2 means what? r2 அப்படியே நியூமரேட்டர்ல போய்டும். So what is it? r2 by r1. So இதுக்கு ஒரு standard result. What is it? If we are giving the same charge means what is the ratio of their potentials? அது என்னது? r2 by r1. அடுத்த comparison பாருங்க, two conducting spheres radius r1 r2 have same electric fields near their surfaces. The sphere oda surface கிட்ட the electric field is same. இங்க பாருங்க, electric field ன்னு சொன்னா what is the formula? Near the surface, if the radius is r, charge q is given. What is the electric field near the surface? kq by r square. K ன்னு சொன்னா that is what? 1 by 4 pi epsilon naught. Okay va? So electric field is near the surface is same. அதுல we have to find what is the ratio of their electric potentials. So potential formula என்ன பாருங்க, what is the electric potential formula? kq by r. Okay, so இப்போ ரெண்டுத்துக்கு comparison என்ன? What is the comparison between them? E is equal to what? V by r. E is equal to what? V by r. அதுதானா? ஏன்னா E is equal to what? kq by r square. V is what? kq by r. So compare பண்ணா what is the relation we are having? E is equal to V by r. Okay, so இப்போ பாருங்க, what is the statement? Two conducting spheres, அதோட radius are what? r1 r2 have the same electric field near their surfaces. Okay va? They are having same electric field near the surfaces. Then the ratio of their electric potentials. இப்போ என்ன வேணும் நமக்கு? v1 by v2 வேணும். So இங்க பாருங்க, E is equal to V by r ன்னு சொன்னா E into r is equal to V. அதுதானா? So v1 will be what? E into r1. v2 will be what? E into r2. ஏன்னா electric field is same in both the cases. இந்த ரெண்டு கேஸ்ல electric field is same, right? Okay, so அப்படியே இந்த E cancel ஆயிடும். What is it? r1 by r2. If the electric fields are same near the surfaces, அதோட ratio of the electric potentials என்ன வரும்? It will be coming as what? r1 by r2. So இதெல்லாம் இந்த மாதிரி questions வரதுக்கு there will be lot of scope. அடுத்து பாருங்க, two conducting spheres radius r1 r2 have equal surface charge density. Surface charge density ன்னு சொன்னா what is it? பாருங்க, conducting sphere, right? What is the surface area? 4 pi r square. We are giving a charge q ன்னு வெச்சுக்கோங்க. Sigma என்ன தெரியுமா? q by the surface area. அதுதான் surface charge density. Okay வா? So they are having the same surface charge density. அப்பனா the ratio of their charges is, okay, so same surface charge density ன்னு சொன்னா first sphere ஓட surface charge density எவ்வளவு வரும்? If say அதோட charge q ன்னு வெச்சுக்கோங்க. So q1 divided by 4 pi r1 square, that is equal to what? q2 divided by 4 pi r2 square. அப்படியே அந்த 4 pi cancel ஆயிடும். Ratio of the charges ன்னு சொன்னா q2 இந்த பக்கம் வரும். Take the r1 square to the right side. பாருங்க, q1 by q2 எவ்வளவு வரும்? It will be what? r1 square by r2 square. So the ratio of the charges என்னது? r1 square by r2 square. Okay வா? So like this we will be able to see some comparison type of questions. Okay, அடுத்தது என்னன்னா, like we do in எங்க properties of fluids la we will have these, you know, drops or bubbles, merging anu sollala, coalescing anu sollala, or breakup. Like அங்க என்னன்னா surface tension base பண்ணி we will have problems, like one big drop is breaking down into smaller droplets, or smaller droplets are combined to form a big drop, then they will ask what is the change in surface energy. And the மாதிரி questions varum enga in the properties of fluid chapter. Okay, so they will be asking us to find what is the change in surface energy or how much energy is required. And the மாதிரி questions varum. Inga parunga, each drop is like a it's like what, a spherical conductor மாதிரி தானா. Inga if you are having small drops means we can merge them and make a bigger drop. If you have a bigger drop means apade we can break it and then form small drops. So this is an interesting case. Paranga, what is it? Merging or breaking up. So inga paranga, n charge drops, each capacitance evla C, charged to a potential V with a charge Q, surface density sigma, potential energy U. They coalesce to form a single drop. They coalesce to form a single drop. And so now what is it? We are having small drops irka. What is the count? N number. Okay va? Adella merge aite, we are getting one single drop madri varudhu. One single big drop is coming. Okay va? So inga they will be asking us what is the charge on that bigger drop, what is the capacitance of the bigger drop, what is the potential of that bigger drop, and madri, what is the surface density of the bigger drop, what is the energy of the bigger drop. Okay va? So C is the capacitance of each of these small drops. They are all having a potential V. Each of them is having a surface density sigma. Each of them is having a potential energy U. Adella apadiye nama coalesce panna, merge panna, we are getting a big drop. Okay va? We have to find what is the capacitance of the bigger drop, what is the potential of the bigger drop, what is the charge of the bigger drop, what is the surface density of the bigger drop, and what is the potential energy of the bigger drop. First we will take each of these small drops is having a radius small r and the bigger drop or radius capital R. Each of them is having how much radius? Small r, small drops. Coalesce பண்ணதுக்கு அப்புறம் we are getting a bigger drop, right? So let us say bigger drop or radius capital R வெச்சுக்கோங்க. இங்க என்ன தெரியுமா? The total volume initially, total volume ன்னு சொன்னா we are having n number of drops. Each drop ஓட volume என்ன? 4/3 pi small r cube. That is equal to total volume finally. Okay va? So இங்க பாருங்க, what is the result that we are getting? ரெண்டு பக்கம் நம்ம cube root எடுத்தா n power 1/3 into small r is equal to capital R. This is an important result. First result. And the bigger drop or radius. What is the radius of the bigger drop? N power 1/3 into small r. That is the bigger drop or radius. Okay. After that, we will just look at each of them. Okay. One by one. So we will have to find out. We should find out what is the charge on that bigger drop. Charge is simple because each of the small drops is having a charge Q. That's merge pannittu we are getting the bigger drop, right? So charge on the bigger drop, paranga. The bigger drop mela what will be the charge? N times of small q. Each of these small drops is having a charge q. அந்த மாதிரி எத்தனை drops இருக்கா? N drops are there. So total charge எவ்வளவு வரும்? N into q. So the charge on the bigger drop அதாவது N into q. ஓகேவா? Charge on the bigger drop எவ்வளவு? N into q. அடுத்து பாருங்க, அந்த bigger drop ஓட capacitance. See, bigger drop ஓட capacitance ன்னு சொன்னா what is it? What is the capacitance of the bigger drop? பாருங்க, what is the capacitance? Spherical capacitor தானா? What is it? 4 pi epsilon naught into capital R. So capital R பதிலா நம்ம என்ன replace பண்ணலாம்? 4 pi epsilon naught into n power 1/3 small r. இது என்ன பாருங்க, n power 1/3 into 4 pi epsilon naught small r. What is 4 pi epsilon naught small r means? Initially நம்ம கிட்ட இருக்கிற each drop ஓட capacitance அது என்னது? C. பாருங்க, n power 1/3 into C. The bigger drop ஓட capacitance value என்னது? n power 1/3 into C. இதெல்லாம் standard result மாதிரி நம்ம derive பண்ணிட்டு இருக்கோம், but we will have to also try to remember them if possible. ஓகேவா? So bigger drop ஓட charge value என்ன? N into Q. Capacitance எவ்வளவு? n power 1 by 3 into c. இந்த ரெண்டு வேல்யூஸ் மட்டும் நம்ம சார்ஜ் ஈஸி தான், அதில் அவ்வளோ பெரியது கிடையாது. கெப்பாசிட்டன்ஸ் மட்டும் if you are able to look at it right, மற்றதெல்லாம் we will be able to derive. ஏன்னா இந்த ரெண்டு ரிசல்ட்ஸ் நம்ம கிட்ட இருக்குன்னு வச்சுக்கோங்க. அதர் திங்ஸ் we can derive by ourselves. எப்படி தி பொட்டன்ஷியல் எவ்வளோன்னு கேட்குறாங்க பாருங்க. வாட் இஸ் த பொட்டன்ஷியல்? இப்போ சார்ஜ் இருக்கா, கெப்பாசிட்டன்ஸ் இருக்கா. பொட்டன்ஷியல்னு சொன்னால் வாட் இஸ் த பொட்டன்ஷியல்? சார்ஜ் பை கெப்பாசிட்டன்ஸ். என்ன பாருங்க, n power 2 by 3 into q by c. q by c ன்னா what is it? That is the original ஒரு ஸ்பியரோட voltage. So what is it பாருங்க, n power 2 by 3 into v. ஓகேவா? அந்த மாதிரி மற்றதெல்லாம் we can derive it. Okay, so if you are able to look at the charge and capacitance, அந்த ரெண்டு வேல்யூஸ் இருந்து வச்சுக்கோங்க, அதுல இருந்து we can derive the other things. ஓகேவா? அடுத்தது என்ன பாருங்க, surface charge density. See, surface charge density, what is it? Charge divided by surface area. Surface area is what? 4 pi capital R square. Capital R badala we write it as what? n power 2 by 3. So total என்ன வருது பாருங்க, what is it coming? n power 1 by 3 q divided by 4 pi small r square. This is our original surface charge energy sigma dana. So what is it coming as? n power 1 by 3 into sigma varudhu. So what is the surface charge density of the bigger sphere? It is what? n power 1 by 3 into sigma. Okay, at the final result enna parunga, total potential energy. So potential energy nu sonna, what is the potential energy? What is the potential energy parunga? The in the formula use பண்ணலாம், we can use half capacitance into potential square. இந்த formula use பண்ணலாமா? So half capacitance எவ்வளவு? n power 1 by 3 c into potential the square. Okay, then what is it? Half into the capacitance c into potential the square. Okay, so idhil we will be able to get what is the potential energy oda comparison. Okay, then a potential energy sonna we will have to use this relation, right? Either q square by 2c நம்ம யூஸ் பண்ணலாம், or half cv square யூஸ் பண்ணலாம், or half q into v அந்த மாதிரி. ஓகேவா? So this is how we will be able to get the relation in terms of the potential energy. Okay, so this is about the small drops merging into form a bigger drop. Then the small drops are merging to form a bigger drop. Okay va? அடுத்த கேஸ் என்ன வரும்? The big drop breaking down to fall smaller drops. Next another bigger drop can be broken down to form smaller drops. Okay, அது எப்படி வரும்? We have to look at it. Okay, so பாருங்க, what is it? If you are having a single drop of capacitance c with a charge q that is divided into n small drops, what is the capacitance of the each drop? Maximum தெரியுமா? They will be asking us questions only on the capacitance based பண்ணி தான் they will be asking us. இங்க அப்படியே reverse தானா? Look at it. We are having a bigger drop of radius capital R. அதை அப்படியே break பண்ணிட்டு we are getting smaller drops. n number வருது, each of them is having a radius r. இங்க the same result, right? What is the relation? 4 by 3 pi capital R cube is equal to n into 4 by 3 pi small r cube volume. Okay, so what is it? Capital R is equal to n power 1 by 3 into small r. Capital R is equal to what? N power 1 by 3 into small r. Okay va? Capacitance of the smaller drops. Okay, so capacitance, now what is it? Capacitance is equal to what? 4 pi epsilon naught into small r. Paranga. So 4 pi epsilon naught into small r is what? Now paranga, what is small r? Capital R by n power 1 by 3. That is small r. then we can write it like this, capital R into n power minus 1 by 3. Okay, what is this? These are original capacitance. Either we'll say original capacitance divided by n power 1 by 3 or n power minus 1 by 3. That is the new capacitance. In the form of one capacitor capacitance evla original bigger drop or capacitance C divided by n power 1 by 3. Okay, wow. So this is the case of breaking up. And in the rendu result pattu namak nabagam vechukonu. What is it? Merging la, if you are able to get the capacitance and the result is important. What is the most important result? Inga parunga, previous case la enna nama n number of small drops edutittu merge panna, the capacitance of the bigger drop formed will be what? N power 1 by 3 into C. Okay, where C is the small drop oda capacitance. Okay, inga parunga apdiye reverse la varum. What is it? If you are having a bigger drop, adu break pannittu we are getting smaller drops nu vechukonga. Then small drop oda capacitance evla? So small drop capacitance adenade parunga bigger drop oda capacitance divided by n power 1 by 3. Okay va? So in the madri questions kekala. What is it? A spherical drop of capacitance 1 microfarad is broken into 8 drops of equal radius. Inga parunga. So it's like what? Bigger drop broken into ethni 8 drops. Means n is equal to 8. The capacitance of each small drop straight. When the formula we will be able to straight away solve. Small drop or capacitance. What is it? Small drop capacitance evla? Bigger drop capacitance, which is 1 microfarad divided by n power 1 by 3. N evla 8. 8 power 1 by 3 means what? Cube root of 8. Cube root of 8 evla? 2 dana. So which is what? Half microfarad. So what is the answer for this? Option A varum paranga. Okay, check pannunga. So what is the answer for this? Option A dana. So in the madri questions varala based on the concept of merging and breaking down. Okay, so idhila like the thing that you need to remember is what? Capacitance formula mattum if you are able to remember means that is good enough. And a maximum they will be asking us only about the capacitance. Okay, so this is about the spherical drop or merging and breaking up into smaller parts. After the paranga, we can have some modifications. Modification and there is a spherical capacitor consisting of two concentric spherical conductors. So outside we have one, two concentric. Okay va? So inga paranga, outer radius enadhi R1, inner radius enadhi R2. Outer edukku mela we are giving a charge Q, inner odidilla we are having a charge minus Q. Okay va? So where R1 and R2 are the radius of the outer and inner spheres. So in the particular arrangement of capacitance, what is the capacitance formula? 4 pi epsilon naught into R1 R2 by R1 minus R2. In the arrangement of capacitance value another 4 pi epsilon naught R1 R2 by R1 minus R2. This is we can derive it. So let us just name them as the outer the 1 and inner 2. Okay, so we will try to calculate what is the potential on the surface of the two. So surface of the two and sonna, see, charge on that surface 2 will create a potential. Other value what will be the value of that? K into minus Q by R2. And if you take a point on the surface to right, that is like a point inside the outer spherical shell. So that also will create a potential. What is that potential value? KQ by R1. This is like potential at a point inside madri. This is like a potential at a point inside. So on the surface of the inner spherical capacitor நீங்க ஒரு பாயிண்ட் எடுத்தா that will get potential due to the charge on that inner shell and we will get a potential. This is the potential because of the charge on the inner shell. Okay va, this is the potential due to the charge in the inner shell. Adanadhu parunga, this is the potential due to the outer shell oda charge. And the formula eppadi varudhu, that is like a point inside the shell. Enna, because remember, for a shell potential on the surface is equal to potential at every point inside. Adanal the value will be what? Kq by r1. Adanal the value will be what? Kq by r1. Okay, adutha parunga, we will look at potential on the surface 1, outer surface mela. Okay, anga eppadi theriyuma, charge on the inner also will create a potential. Charge on the inner will create a potential. Adoda value enna varum parunga, k into minus q by r1. Enna, this is like a point outside. So this is the spherical shell. We are looking at a point outside. Formula enna varudhu? K into charge on the shell divided by distance from the center of the shell and நம்ம measure பண்ணனும். அதானது r1 வரும். அந்த மாதிரி shell 1 மேலே we are having charge, right? Q. So அதோட potential. So நமக்கு என்ன, we are looking for the potential difference தானா? We are looking for the potential difference, right? So அந்த ரெண்டோட டிஃபரன்ஸ் நம்ம கால்குலேட் பண்ணனும். So what is the potential difference? இங்க பாருங்க, potential difference எவ்வளவு வரும்? Potential difference ன்னு சொன்னா என்னது? What is it? We will have to subtract them, right? We will have to subtract them. So subtract பண்ணா என்ன? What is it that we are going to get? பாருங்க, இதுல which is a higher one? R1 is a higher. R1 is more than R2. Okay வா? R1 is actually more than R2. So V1, right? V1 value will be higher. Okay, so adhanala we will just do what? V1 minus V2 panla. So V1 minus V2 panna, what is it? In the rendu term cancel adum, common. So look at this, V1 minus V2, if you do, what you will have? K into minus Q by R1 minus of K into minus Q by R2. Idhula minus minus becomes plus. What is finally? Kq by R2 minus Kq by R1 madri. What is it? Kq nama common edutha, R1 minus R2 by R1 R2. That is our potential difference between the two plates. Capacitance and another, capacitance is what? Charge divided by the potential difference, right? Which is what? Okay. So QQ cancel ஆயிடும், R1 R2 numerical போயிடும். So இங்க நம்ம என்ன பண்றோம்? We are looking at what is the potential difference between the two plates. The potential difference value வச்சிட்டு we are able to find what is the capacitance, because capacitance is what? Charge divided by the potential difference. அதுதானா capacitance ன்னு சொன்னா என்னது? What is it? Charge divided by potential difference. இங்க பாருங்க, so capacitance எவ்வளவு வருது? R1 R2 by K into R1 minus R2. இங்க பாருங்க, K denominator இருக்கா? So K is what? இது எப்படி 1 by K மாதிரி தானா? 1 by K means what? 4 pi epsilon naught. So 4 pi epsilon naught R1 R2 by R1 minus R2. இதானது the capacitance value. இதான் இங்க இருக்கு result. So what is the capacitance of this particular arrangement? இதானது பாருங்க, we are giving charge Q to one of the surfaces minus Q to other surfaces. Okay, so one surface we are giving a charge Q. In one surface we are giving charge minus Q. What is the capacitance of that particular arrangement? 4 pi epsilon naught R1 R2 by R1 minus R2. Okay va? So we are making a capacitor by using two spherical shells. Two spherical shells which we are making a capacitor. Okay, and this is another modification. The spherical conductor enclosed by earth concentric spherical shell. This is the spherical conductor. That radius A. spherical conductor அதோட radius எவ்வளவு a ஓகேவா it is enclosed by earth concentric spherical shell means this is a spherical shell outerல we are having a spherical shell ஓகேவா that is connected to the earth அதனால what are we calling it as we are calling it as earth ஓகேவா அப்படி பண்ணா என்ன ஆகும்னா like look at it if we are giving a charge q okay to the inner spherical conductor நம்ம inner spherical conductor மேல we are giving a charge plus q னு வெச்சுக்கோங்க then அந்த outerல இருக்கிற spherical shell right charge gets induced எப்படி தெரியுமா so உள்ள இருக்கா plus q இருக்கா so charge gets induced எப்படி அதோட inner surface மேல we will get a negative charge outer surface மேல we will get a positive charge but என்னன்னா outer surface is connected to the earth right அதனால whatever the charge here அப்படியே will be going to the earth ஓகேவா so என்ன ஆகும் overall the outer concentric spherical shell right அதோட inner side ல we will get a negative charge value same okay so in case of the conductor side induced charge will be equal to the original charge right அதாவது நம்ம நிறைய examples பார்த்திருக்கோம் in case of conductor induced charge is equal to what the original charge இப்போ பாருங்க என்னது the inner side of that concentric shell right will be getting a negative charge how because of the induction அதோட outer side la whatever the positive charge that is created due to induction right அப்படியே that is a transfer to the earth அதனால we are not representing it ஓகேவா so this is another modification இங்க என்ன தெரியுமா இதுவும் ஒரு capacitor மாதிரி தான் we can find what is the capacitance value இங்க என்ன we can find what is the capacitance value okay same approach first and we have to calculate what is the potential difference between these two what is the potential difference between these two spherical surfaces okay so for example இத நம்ம மார்க் பண்ண வெச்சுக்கோங்க 1 and 2 னு சொல்லிட்டு மார்க் பண்ணா we have to find what is the potential difference between the two அது எப்படி same நம்ம இதுக்கு முன்னாடி பண்ண மாதிரி தான் we will have to find out what is the potential on that surface 1 அந்த மாதிரி we have to find what is the potential on the surface 2 பண்ணா we are going to get same result வர போறது okay so potential will be coming as what பாருங்க q by 4 pi epsilon naught b minus a by b into a and சொல்லலாம் or a into b இதுக்கு முன்ன நமக்கு வந்த மாதிரி தான் what is it we got before kq by kq means what q by 4 pi epsilon naught தானா so kq by b minus a by a into b இங்க அங்க என்ன வருது r1 minus r2 by r1 r2 okay so we are going to get the same result இங்க பாருங்க what is it that we can write இத நம்ம எப்படி எழுதலாம் what is it k q into r1 minus r2 by r1 r2 அதுதானே இதுக்கு முன்ன நமக்கு வந்த ஃபார்முலா same result will come okay so இங்கல இருந்து we are going to get the capacitance also so capacitance will be what charge by potential அதுதானே capacitance will be what charge by potential so we are going to get same result here also இதுக்கு முன்னாடி நமக்கு என்ன ரிசல்ட் வந்தோ same as it is we are going to get the result what is it 4 pi epsilon naught a into b by b minus a ஏன்னா this is b is like what r1 மாதிரி ஜாஸ்தி higher value a is like our r2 compare பண்ணும்போது with the previous result ஓகேவா so this is what one spherical conductor which is enclosed by a concentric spherical shell ஓகேவா so result will be same இதுக்கு முன்ன நமக்கு எந்த ரிசல்ட் வந்ததோ we are going to get the same result here also ஓகேவா so this is about the modification of the spherical capacitor okay அடுத்தது என்னன்னா this is another important standard result cylindrical capacitor இது என்ன தெரியுமா a cylindrical capacitor consists of cylindrical conductor இங்க பாருங்க உள்ள இருக்க ஒரு cylindrical conductor இருக்கா ஓகேவா so உள்ள இருக்க there is a cylindrical conductor இந்த சிலிண்டரோட length L ன்னு வெச்சுக்கோங்க ஓகேவா and the inner the cylindrical conductor oda radius என்னது a surrounded by a coaxial cylindrical conducting shell surrounded by what அதுக்கு வெளியில we are having a coaxial ன்னு சொன்னா ரெண்டுத்துக்கும் ஒரே axial line ஓகேவா surrounded by a coaxial cylindrical shell which is earthed அதோட outer surface earth பண்ண மாதிரி இதுக்கு முன்னாடி நம்ம பார்த்து தெரியுமா as it is so இங்க என்னது the outer surface is earth right அந்த மாதிரி தாங்க so the outer part is actually connected to earth அப்ப என்ன தெரியுமா there will be a negative charge induced இங்க பாருங்க negative charge induced on the inner அந்த outer இப்போ பாருங்க இந்த outer இப்படி இருக்கா அதோட thickness னு வெச்சுக்கோங்க அதோட inner sideல negative charge induce ஆயிடும் லைக் இதுக்கு முன்னாடி நம்ம பார்த்த மாதிரி சோ இப்போ பாருங்க இதோட capacitance இங்க நம்ம derive பண்ண போறது கிடையாது we are just going to look at the final result okay so இதோட capacitance எவ்வளவுன்னு பாருங்க 2 pi epsilon naught into L. L is the length of the cylinder divided by ln B by A. B is what? The outer cylindrical shell order radius B, higher value. A is what? Inner cylindrical conductor order radius. Okay, what is it? This is the capacitance of the cylindrical capacitor. Maximum idella varadu, but in case we get some questions, right? We should be ready with these at least formula mattu. We should be knowing it. Okay. So this is about the cylindrical capacitor. அடுத்து பாருங்க last concept if you are having two spherical shells with like charges so let us say for example இதோட radius a ன்னு எடுத்துக்கோங்க outer one so two spherical shells which are concentric that's important they should be what concentric means they should be having the same center okay so let us say இதோட charge q1 இதோட charge q2 okay so inner oda charge anadhu q1 outer oda charge q2 ipo enna we will try to calculate what will be the potential on that surface 1 and what will be the potential on surface 2 so surface 1 mela potential ennu sonna q1 will produce the potential right adoda value enna varum paarenga k q1 by a and madri q2 also will produce a potential அதோட வேல்யூ என்ன வரும் kq2 by b வரும் ஏன்னா because this is the formula for potential at a point inside this is the formula for potential at a point inside so q2 is the outer shell right the potential on the surface of the outer shell will be equal to potential at every point inside அதனால what is the formula we are going to get q2 by b வரும் அந்த மாதிரி இங்க பாருங்க we are going to look at potential on that outer surface v2 q1 will produce a potential there what is the formula k q1 by b this is the formula for what this is the formula for potential at a point outside adana adukaprom q2 will produce the potential in itself right adoda value enna k q2 by b paranga k q2 by e is same in both the things ரெண்டுத்துலயும் சேம் தானா இப்போ சொல்லுங்க let's say for example I am saying q1 and q2 positive ன்னு சொன்னா வெச்சுக்கோங்க both are positive q1 and q2 positive okay so which means what the q1 value here என்ன second term ரெண்டுத்துலயும் சேம் தானா first term மட்டும் நம்ம கம்பேர் பண்ணனும் இங்க பாருங்க இதுல என்ன numerator kq1 இதுல numerator kq1 சேம் டிஃபரன்ஸ் எங்க வருது வெறும் இந்த denominatorல மட்டும் b is more than a b is more than a so v2 oda denominator b varudhu so adanal what is the conclusion v2 will be less than v1 and v2 case la what is the denominator b right denominator b varudhu so it will be what other value will be lesser and b is higher right b higher adanal v2 will be lesser which means v1 is going to be higher idana theriyuma the inner shell will be at a higher potential and carefully paranga we have not given any value to the charge நம்ம அந்த values கொடுக்கல whatever may be the charge values right whatever may be the charge values whenever the result potential on the inner shell is higher than the potential on outer shell அப்ப என்ன தெரியுமா just simply யோசிச்சு பாருங்க if you are connecting the inner and outer by a conducting wire அப்படி நம்ம கனெக்ட் பண்ணா what is going to happen whatever charge given here right அது அப்படியே will keep going to the outer shell whatever the charge we are giving to the inner shell right will keep going to the outer shell. Because the inner shell is at a higher potential than the outer shell, irrespective of the charge or values. Charge or values relation illame always will be having what? Inner shell is having a higher potential than outer shell. Okay, so whatever charge given to the inner shell, right, will keep going outside. In the concept based panni, we have a device called as Van de Graaff generator. In the concept namu therinja podum enna, because this is taken out of the syllabus now. Ipo in the Van de Graaff generator concept syllabus la kadiyadu. Van de Graaff generator enna theriyuma, based on the same concept. So ulla irukra spherical shell mela you keep on supplying charge. Appo enna theriyuma, apdiye the charge will keep going to the outer shell. Whatever the charge given to the inner shell, right, it will keep on going to the outer shell. As a result, we will be able to build up very high potential differences. As a result, we will be able to build up very high potential differences. High and so it will be in very large value, in the range of millions of volt. Okay, so whatever the charge given to the inner, right, that will keep going away, means that will keep going to the outer shell. So we will be able to build what? Very large potential difference. Outer shell mela we will be able to get lot of charge value. Adanala we will be able to achieve very high potential differences, and that device is called as what? Van de Graaff generator. Okay, but on the device adoda working principle adala syllabus la kadayadu. The thing is, on the concept mattum therinja podum. What is it? If you are having two concentric shells, whatever may be the charge on the shells, whatever may be the charge values on the shells, right, another, if we look at the potential values on these shell surfaces, what do we see? We'll see that if the charges are positive, what do we observe? Inner shell is having a higher potential than outer. So whatever charge given to the inner shell, right, will keep moving to the outer shell. Why? Because charge will flow from high potential to low potential. If you change the side, if you take the charge to be negative, right, inner will be at a lesser potential, but negative charge eppadi move agum? Negative charge will be moving from low potential to high potential, right? So same ange charge given will again move from the inner shell to outer shell. So always what we are going to have? We are going to have the condition that whatever charge given to the inner shell, right, adu appadiye keep on moving to the outer shell. That device is called as what? Van de Graaff generator. Okay va? So this is about the idea of the Van de Graaff generator. Idoda we have completed the discussion about the capacitors. Okay, so practice pannunga. So whatever the relevant models of questions, past year questions, adala practice pannittu. If you are getting stuck in somewhere, means we can discuss those questions as well. But idoda we have completed the discussion about the electric potential and capacitor. After that we will go into the current electricity chapter. Okay.